Okay, piecewise and step graphs. So piecewise graphs or step graphs are basically just graphs where the nature of the equation changes over different domains or over different ranges of x values. So, for example, if I was to draw you an axis quickly, basically I might have a graph where I have sort of one gradient over a certain domain. So that would be my initial domain is here from 0 to whatever this first x value is. And then my gradient might change and I might sort of have a different gradient altogether for the next section. So I would have a different equation between x1 and x2. And then I might have, so on, I might have several sections, and over each section there would be a different equation to be calculating. A step graph is much the same, except the graph sort of steps. So I'll show you what that looks like. So basically I might have a graph where I would have something like this. And so we call it a step graph because, as you can see, it looks like a series of steps. And I'll elaborate on these symbols and whatnot as we go. So basically that's what they're going to look like. The notation that you need to have in mind is that we generally say that each part of the graph is f of x, it's a function of x, and then we would generally write down the equation for each part of the line, which is going to be in the form of your y equals mx plus b. They're generally going to be linear because our course is linear. We actually don't need to write the y in because the f of x is already effectively y, it replaces y, so f of x is really just y. So we give the equation and then we give the domain over which that equation happens. So for x is equal to greater than 0 and less than whatever that first cutoff is, and then I would have my next equation, so it's going to be another mx plus b, and obviously they're going to be different numbers. But I'd find out the equation for the next section, and that would happen in between x1 and the whatever my next cutoff is, x2. And you're going to have all these symbols. Now, the first thing we need to understand is what the open circles and the closed circles mean. So basically in all of these graphs, an open circle means that I've got a less than or a greater than sign, and so I show that it doesn't actually include that number with an open circle. And a closed circle means that I've got a less than or equal to, or greater than or equal to. So the closed circle shows that it actually includes that number. So for example, if I was looking at that step graph, if I was at this particular x value, as I came up here, I'd know it's not this here because that's an open circle, and so I'd read my solution from the second one, which is closed, and I'd read my answer off here. Or likewise, if I was at x2 here, then I wouldn't go to here, I'd go up to the next one because that's closed, and I'd read my answer from there. So that's those. So let's do a couple of examples. So the first one, it says on the given number lines, graph the following intervals. So if x is less than 2, the first thing you'll notice is I've got a less than but not equal to, so I'm going to use an open circle. So at 2, I would have an open circle, and I know that this equation is any x values less than that, and so the rest of my line would basically head in this direction. And because it would continue forever, I just put an arrow on the end of it. I'll change colours to something a little bit darker. If I did number 2, it says that x is greater than or equal to 1. So because I've got the greater than or equal to, I'm going to use the closed symbol, and that's going to start at 1. So I'd use the closed symbol there. And then x is going to be bigger than that. So I would then take my line out in this direction, so it's going to be bigger than, and again, because it continues forever, I'd put an arrow on the end of that. The next one, I have 2 open symbols, so I've got this would read that x is greater than -3 or x is less than 2. And so at both of those numbers, at the -3 and also at the 2, I would have open symbols because I have the no equal sign. And then basically I would fill that in with a line in between. And that would show me that x can be anywhere between -3 and 2, but doesn't actually include those numbers. In your next one, you've got greater than and or equal to sign and a less than or equal to sign. So here it says that x is greater than or equal to 0 and less than or equal to 3.5. So again, I need a closed circle at the 0, a closed circle at the 3.5, and x is going to be lying in between those. So I'd show that with a line in between Try and keep that neat. There we go, a line in between those. So I think you get the gist there. For some of them you have two different symbols. So one's, this one here would be a close, this one here would be open. So X, it reads that X is greater than or equal to negative 1.5. So I would put a closed dot at the negative 1.5. And X is less than 2.5, but not including the 2.5. So that would be an open symbol there. And then I would put the line in between that. So keep an eye on the symbols. Typically there's a mark for having the right symbols and a mark for having the right locations and that sort of thing, depending on how complicated your question is. So this is the classic example of how they're going to set these out. So you can see they've got y equals, often they'll replace that with an f of x, it doesn't matter, but y equals, and then they use that set notation. So you can see they've used the little set symbol there, and that means I'm going to have three sections of my graph. So in my first section, which is going to happen from the domain x is equal to negative 3, greater than or equal to negative 3, and x is less than 1. The equation itself, 2x plus 1 is linear, as we can see, and we would know, hopefully, that if I was going to graph this, the easiest place to start is at this 1. That would show me my x-axis intercept, and then the gradient of 2 would allow me to then graph that. So if I go ahead and start graphing, my first dot would be at the 1. Now this, that's my y-axis intercept. Now this domain, so I'm just going to put a dot there at the moment, not an open or 1. So I know I'm going to head through 1. And my line itself with a gradient of 2 means I'd go up 2 and across 1. So if I was doing that, up 2 and across 1 is basically where I'm going. And if I did it again, up 2 and across 1, that gives me sort of where my line's going to go. But this line actually only happens between 1 and the negative 3. So I'm going to carry this down. I can do it in reverse, so I can go down 2 and across 1, just to make sure I get this right, down 2 and across 1, and I want to go to negative 3, so down 2 and across 1. Now, at the negative 3, I have a closed symbol, and at the 1, I'm going to have an open symbol. So first I'm going to put my line in. I know my line's going to go to here, keep it nice and straight. At this point, though, I'm going to have that open symbol, and I've probably made that a little bit messy, but hopefully I'll have to get rid of those dots. That's got rid of everything, but that's all right, we'll go again. So we know we were going to end up there, and what we need is that open symbol at that end. Okay, so that would be my equation. You can see I've made use of my y-axis intercept being the 1, because I could see it in this case. I've made use of the gradient, rise of 2 for a run of 1, and I have correctly, so my line's going to be correct, and I've correctly put in the correct symbols at either end. Now my next section of the graph, I'll change colours for it. My next section of the graph says that y is equal to 3, which means it's going to be a horizontal line at 3, because y is never changing. And that's going to happen in between x being greater than or equal to 1 and x being less than the 4. So again, the domain here is in between 1 and 4, okay? So it's a set number. X is greater than or equal to, so in theory I have a solid dot there. These are going to overlap with each other, of course, and that's going to go across to the 4. It was less than, so I should have an open symbol at the 4. Now once I get to the 4, I'm now on to the next section of my graph, okay? And in this time, I know this is going to go on between 4 and 7, so if I just change my colours here, this is going to go on in between x is 4 and x is 7, so that's going to be my domain. But this would be a little bit trickier to graph. So normally we'd look for the 15 on the axis and we'd start there, and then we've got a gradient of negative 3, so we'd go down 3 and across 1. But this is going to be tricky to do in this case because I don't have a 15 on the axis. So if that's the case, and even when it's not the case really, it's often easier just to make use of the equation and use the two cutoffs that's what you're going to substitute in to graph it. So I know my equation is 15 minus 3x. And I'm going to replace the x with the two numbers that form the cutoffs, the 4 and the 7. So 15 take 3 times 4 being my first cutoff. So 3 4s are 12. So 15 take 12 is going to give me a 3. So when x is equal to 4, this will be equal to 3. So I will colour that in there. And the next number, my last cutoff was the 7. So again, I've got the same equation, 15 take 3x, but in this case, my x would be 7. So 7 threes are 21, so I'm going to wind up with 15, take my 21. Eventually I can just go 21, take 15, and I know that that's 6. The bigger number was a negative though, so my answer will be a negative 6. And so when x is equal to negative 7, y would be 6, and this was including the 7, so I'd put a solid dot, and so my line basically is going to come down there, and that would be my piecewise function. The open and closed symbols in this case, in the centre of the graph, it became a bit of a moot point because of the overlap between the equations. And so that sort of makes them filled in anyway, but at the extremities here at the far ends, they were important to have those right. Okay, so that was the first part of the question, graph the piecewise equation. They said to do it on your calculator. Can't remember if I haven't put the calculator notes in there. In the calculator you can still do this though, so if you go on, so I'll just turn mine on so I can talk you through the instructions. If you go into your graph mode, and then basically you have to open up your keyboard